Hello everyone, today we're going to be looking at another brain teaser, Quantipus number 24, in which we're given a 2-pan balance scale and 9 indistinguishable beans, exactly one of which is slightly lighter than all the others. And it's asking us what's the minimum number of weighings needed to guarantee finding the lighter bean. So we have 9 indistinguishable beans and we're trying to find the odd one out, and we're trying to do it in the minimum number of weighings as possible. So that basically means that we're trying to maximize the amount of information that we get per weighing. Well, here we go. I drew a little representation of a balance scale, and what possible outcomes does a balance scale have? Well, it can either tip down in this direction, or it could tip down in this direction, or it could be balanced. So that essentially gives me 3 possible outcomes, right? They can either be equal, and I'll call this the scale goes up in one direction, or the scale goes up in the other direction. So what this means is that we can essentially cut our input space in 3 every time we do a weighing. Well, how do we actually do this in this situation? Well, let's just say that I had a group of beans here and I had another group of beans of the same size, and I put it on the other side of the scale. And then if one side of the scale goes down, I'm going to know that the lighter bean's in group 2. Similarly, if this side of the scale goes down, I know the lighter bean's in group 1. And then if the scale balances out and they're equal, then I know the lighter bean is in the group that I didn't weigh. Let's call that group 3. So if I have my 9 beans represented by these circles, well, a group of 9 is pretty easy because it's divisible by 3. All I do is initially I divide this group into 3 groups of 3 like so, and then I take any 2 of these groups. Let's say I divided them into 1, 2, and 3. Let's say I took groups 1 and 2 and I weighed them against each other, and whichever outcome I had would tell me which group the lighter bean is in, like we discussed. Now, once I know which of these 3 groups the lighter bean was in, like let's just say for sake of argument it was in group number 1, then all I do is I divide this subspace into 3 groups of 3, so each individual bean, and I weigh any 2 against each other, and since I have 3 outcomes, it should tell me in 1 more weighing. So how many total weighings did this take? Well, 1 to distinguish which group of 3 it was, and then another to distinguish which one was the lighter bean within that group of 3, so 2 weighings. You can also think about this like a tree. Say I have n beans to start, and then each weighing is going to split my outcome space into 3, and then each weighing after that will further split into 3, and so basically my branching factor is 3 in this tree, and the number of weighings will be the height. And then the height of this tree is going to be log base 3 of n. So we can come up with a generalization. Let's say k is the number of weighings, then that's going to be equal to essentially log base 3 of n, right? Since n was 9 in our situation, well, what's log base 3 of 9? It's essentially saying 3 to the k equals 9, and we solve for k. So k is going to be 2 in this case, which we found right here. And since k is the number of weighings, it basically has to be an integer. Like for instance, say we had 10 beans to start, well then you can see that 2 weighings will not be enough to distinguish 10 beans because 3 squared is 9, and that's going to be less than 10, right? So we want the smallest k essentially such that this is going to be greater than or equal to this, right? The number of groups that we can distinguish between, we want that to be higher than the number of beans that we start with. So for the full generalization to n beans, it's going to take us, this is essentially like saying that k needs to be equal to the log base 3 of n, and since it needs to be an integer, we take the ceiling of that. So the answer to the 9 bean question was 2 weighings, and our generalization to n beans is going to be the ceiling of log base 3 of n.